welcome back. It is Tuesday evening. Monday, Tuesday, Wednesday. It's Tuesday and I just eat some food. It's a little hot in my apartment. So I just eat food and I got a shower this evening. I like to read about the Russian MIG-25 and the MIG-23, but not from there. We do it on here on Adobe Acrobat. I read it the same time when the computer voice is reading. I read the text same time. Yes, need to read this glider aircraft. I was flying glider when I was a teenager. Actually, a motor glider will be very good to go traveling. So that's a lot of aircraft. I like to read about the solar system, the planet Mars, different kind of glider classes. But this is very good. This same here Nimbus 4. It have an engine you can take off by yourself. But I think that's, I like to read all this. Chicago Harbor Airport, Amsterdam Schiphol, Antonov, the Blackbird. I like to read again. But I got many hundred of PDF I like to read about. And this one, the F-15, I like to read about. So I don't know which one. I have to select every day which one to read. And I really like to read about this Panver tornadoes. I really like to read about it. And many more. I think that's another glider. Slickster ASW, that's an open class glider, but they're very old. That's from the 1980s. Only built load 87, and they're built like 50 years ago, 40 years ago. But I think they are very expensive second hands. Yes, let's read Antarctica. Let's read the MiG-25 and I think just continue reading the MiG-23 after this. And I will make a video about it in my language Danish later.
Mikoyan-Gurevich MiG-25. MiG-25 A MiG-25 Pu-2C trainer role interceptor on reconnaissance aircraft national origin Soviet Union manufacturer Mikoyan-Gurevich / Mikoyan first flight 6 March 1964 introduction 1970 status in limited service primary users Soviet Air Defense Forces Historical Indian Air Force Historical Algerian Air Force Historical Syrian Air Force produced 1964-1984 number built 1,186 1 developed into Mikoyan MiG-31. The Mikoyan-Gurevich MiG-25 Russian 25 NATO reporting name Foxbat, is a supersonic interceptor and reconnaissance aircraft that is among the fastest military aircraft to enter service. Designed by the Soviet Union's Mikoyan-Gurevich Bureau, it is an aircraft built primarily using stainless steel. It was to be the last plane designed by Mikoyan-Gurevich before his retirement. 2. The first prototype flew in 1964 and the aircraft entered service in 1970. It has an operational top speed of Mach 2.83. Although its thrust was sufficient to reach Mach 3.2+, its speed was limited to prevent engines from overheating at higher air speeds and possibly damaging them beyond repair. 3. 4. The MiG-25 features a powerful radar and full air-to-air missiles and was theoretically capable of a ceiling of 27 km, 89,000 feet. When first seen in reconnaissance photography, the large wings suggested an enormous and highly maneuverable fighter, at a time when US design theories were also evolving towards higher maneuverability due to combat performance in the Vietnam War. The appearance of the MiG-25 sparked serious concern in the West and prompted dramatic increases in performance for the McDonnell Douglas F-15 Eagle, then under development in the late 1960s. The capabilities of the MiG-25 were better understood by the West in 1976 when Soviet pilot Viktor Belenko defected in a MiG-25 to the United States via Japan. It turned out that the aircraft's weight necessitated its large wings. Production of the MiG-25 series ended in 1984 after completion of 1,186 aircraft. A symbol of the Cold War, the MiG-25 flew with Soviet allies and former Soviet republics, remaining in limited service in several export customers. It is one of the highest flying military aircraft. 5. One of the fastest serially produced interceptor aircraft, 6, and the second fastest serially produced aircraft after the SR-71 reconnaissance aircraft, which was built in very small series compared to the MiG-25. 7. As of 2018, the MiG-25 remains fastest manned serially produced aircraft in operational use and the fastest plane that was offered for supersonic flights and edge-of-space flights to civilian customers. 8. 7. Design and development. Background. During the Cold War, Soviet Air Defense Forces, PVO, not to be confused with Soviet Air Force, VVS, was given the task of strategic air defense of the USSR. This meant not only dealing with accidental border violations, but more importantly defending the vast airspace of the USSR against US reconnaissance aircraft and strategic bombers carrying free-fall nuclear bombs. The performance of these types of aircraft was steadily improved. In the late 1950s, the very high-altitude overflights of Soviet territory by the Lockheed U-2 revealed the need for a higher-altitude interceptor aircraft than available at that time. 9. The subsonic Boeing B-47 Stratojet and Boeing B-52 Stratofortress strategic bombers were followed with Mach 2 Convair B-58 Hustler, with the Mach 3 North American B-70 Valkyrie on the drawing board at that time. A major upgrade in the PVO defense system was required, and, at the start of 1958, a requirement was issued for manned interceptors capable of reaching 3,000 km per hour, 1,600 kn, and heights of up to 27 km, 89,000 feet. Mikoyan and Sukhoi responded. 10. U-152 and U-152M experimental interceptor. The Mikoyan-Gurevich OKB had been working on a series of interceptors during the second half of the 1950s. The I-1, I-3U, I-7U, I-75, U-150, U-150O, U-152, U-152, U-152P, and U-152M. The U-150 was noteworthy because it was built specifically to test Tumansky R-15 engine, two of which would later be used for MiG-25. This led to U-152, alternatively known as U-166, which set several world records. 11. The U-152M, converted from one of the two U-152 aircraft, was intended to be the definitive heavy interceptor design. But before it was finished, the PVO had selected the Tupolev Tu-128. As the work on the MiG-25 was well underway, the single-engine U-152M was abandoned. Development. Work on the new Soviet interceptor that became the MiG-25 started in mid-1959, 12, a year before Soviet intelligence learned of the American Mach-3 A-12 reconnaissance aircraft. 13. It is not clear if design was influenced by the American A-5 Vigilante. 12. The Design Bureau studied several possible layouts for the new aircraft. One had the engines located side by side, as on the MiG-19. The second had a stepped arrangement with one engine amidships, with exhaust under the fuselage, and another in the aft fuselage. The third project had an engine arrangement similar to that of the English Electric Lightning, with two engines stacked vertically. Options 2 and 3 were both rejected because the size of the engines meant that either of them would result in a very tall aircraft, which would complicate maintenance. 12. The idea of placing the engines in underwing nacelles was also rejected because of the dangers of any thrust asymmetry during flight. Having decided on engine configuration, there was thought of giving the machine variable sweep wings and a second crew member, a navigator. Variable geometry would improve maneuverability at subsonic speed, but at the cost of decreased fuel tank capacity. Because their reconnaissance aircraft would operate at high speed and high altitude, the idea was soon dropped. Another interesting but impractical idea was to improve the field performance using two Rode 36-35 lift jets. Vertical takeoff and landing would allow for use of damaged runways during wartime and was studied on both sides of the Iron Curtain. The perennial problem with engines dedicated to vertical lift is they become dead weight in horizontal flight and also occupy space in the airframe needed for fuel. The MiG interceptor would need all the fuel it could get, so the idea was abandoned. 14. U-155R3 reconnaissance prototype with a 5,280 L, 1,390 US gal, dropped tank under the belly. 1964. The first prototype was a reconnaissance variant, designated U-155R1. That made its first flight on the 6th of March 1964. 15. It had some characteristics that were unique to that prototype, and some of these were visually very evident. The wings had fixed wingtip tanks with a 600 L, 160 US gal capacity, to which small winglets were attacked for stability purposes. But when it was found that fuel sloshing around in the tanks caused vibrations, they were eliminated. The aircraft also had attachments for movable foreplanes, canards, to help with pitch control at high speed. Provisions for canards had previously been installed, but not used, on the U-152P. 14. 16. The first flight of the interceptor prototype, U-155P1, took place on the 9th of September 1964. 17. Development of the MiG-25, which represented a major step forward in Soviet aerodynamics, engineering and metallurgy, took several more years to complete. 17. 18. On the 9th of July 1967, the new aircraft was first shown to the public at the Domodedovo Air Show, with 4 prototypes, 3 fighters and a reconnaissance aircraft, making a fly past. 19. Aviation records. The Mikoyan-Gurevich Design Bureau soon realized that the performance of the new aircraft gave it great potential to set new flight records. In addition to their normal duties, the prototypes U-155P1, U-155R1, U-155R3 were made lighter by removing some unneeded equipment and were used for these attempts. Under Federation Aeronautique International, FAI, classification, the U-155 type belonged to Class C1-3, which specifies jet-powered land planes with unlimited maximum takeoff weight. Records set included the first claim was for world speed records with no payload and payloads of 1,002,000 kilograms, 2,205 and 4,409 pound. MiG-OKB Chief Test Pilot Alexander Vasilevich Fedotov reached an average speed of 2,319.12 km per hour, 1,252.22 kn, over a 1,000 km, 621.4 mi, circuit on the 16th of March 1965. 17. For pure speed, with no payload, test pilot Mikhail M. Komarov averaged 2,981.5 km forward/h, 1,609.9 kn, over a 500 km, 311 mi, closed circuit on the 5th of October 1967. 17. On the same day Fedotov reached an altitude of 29,977 meters, 98,350 feet, with a 1,000 kilograms, 2,205 pound, payload. 20. The MiG eventually became the first aircraft to go higher than 35,000 meters, 115,000 feet. 20. Time to height records were recorded on the 4th of June, 1973 when Boris Orlov climbed to 20,000 m, 65,617 feet, in 2 minutes 49.8 s. The same day, POM Ostapenko reached 25,000 m, 82,021 feet, in 3 minutes 12.6 s and 30,000 m, 98,425 feet, in 4 minutes 3.86 s. 20. On the 25th of July, 1973, Fedotov reached 35,230 m, 115,584 feet, with 1,000 kilograms, 2,205 pound, payload and 36,240 m, 118,900 feet, with no load, an absolute world record. 20. In the thin air, the engines flamed out, and the aircraft coasted in a ballistic trajectory by inertia alone. At the apex the speed had dropped to 75 km per hour, 40 kn. On the 31st of August, 1977, U-266M again flown by Fedotov, set the recognized absolute altitude record for a jet aircraft under its own power. 21. He reached 37,650 meters, 123,520 feet, at Podmoskovnoye, USSR in zoom climb. The absolute altitude record is different from their record for sustained altitude in horizontal flight. The aircraft was actually a MiG-25RB re-engined with the powerful R-15B F2-300. It had earlier been part of the program to improve aircraft's top speed that resulted in the MiG-25M prototype. 12. In all, 29 records were claimed, of which 7 were all-time world records for time to height, altitudes of 20,000 m, 66,000 feet, and higher, and speed. Several records still stand. 12. Technical description. Because of the thermal stresses incurred in flight above Mach 2, the Mikoyan-Gurevich OKB had difficulties choosing what materials to use for the aircraft. They had to use E2 heat-resistant plexiglass fourth canopy and high-strength stainless steel for the wings and fuselage. Using titanium rather than steel would have been ideal, but it was expensive and difficult to work with.